my name is Chao, and welcome to a short introduction to my PhD dissertation. In recent years, robots are becoming more sophisticated and physically capable of performing work in home and office environments. However, for the robots to make the transition from highly structured factory environment to assisting humans in home or offices, I believe the key lies in effective communication, since it is useful for reducing uncertainty. This includes developing receptive skills for recognizing and attending to human instructions, and the often neglected expressive behavior for conveying the robot's own state and intentions. Expressive behavior is important because human instructions are highly ambiguous. Even communication between humans can sometimes fail. When that happens, the result can be disastrous. A robot taking actions to convey its status or understanding is a crucial step for reducing uncertainty. Now let's take a look at the sequence of challenges a robot must face when assisting humans. First, the robot needs to navigate the environment and find humans in reasonably cluttered homes such as this. Then it must attempt to recognize the human's intentions from their gestures or postures. After which, like any good communicator, the robot must convey its current status and understanding to the human to reduce uncertainty in the instructions. And finally, the robot makes the appropriate move and repeats the process until the human's needs have been met. The conventional approach to these problems is to resolve them individually, possibly using completely different approaches and frameworks, and an even amount of emphasis is put on each problem. In my dissertation, I tackle these problems from another perspective. I treat these problems as a whole because I believe the knowledge gained from one process can greatly benefit the others and vice versa. In some cases, looking at the problem as a whole actually reduces the difficulty of the problem. I view each problem that includes human modeling and gesture recognition as active processes where actions are involved, so they can all benefit from a behavioral learning framework and encourage knowledge transfer and reuse. Recent advances in neuroscience and psychology have given us new insights regarding how the human brain gathers sensory information, organizes them in a way that benefits future prediction and recall. My work adopts some of these ideas and demonstrates how they can benefit human-robot interaction. For my thesis, I formalize these ideas and present a unified approach for robots to learn behavior interacting with humans. As proof of concept examples, I show how a humanoid robot can learn different variations of the expressive pointing gesture as the result of exploring the effect of manual behavior learned using the same framework. As the robot gathered more experience interacting with different people, it developed a preference for the arm pointing gesture since the gesture is proven to be more effective. After which, I also discuss how other gestures such as beckoning, size hinting, and rejection can all emerge from the same approach. For the receptive behavior, I further illustrate the benefit of the unified approach with an example where the robot learns to interpret a human's intention by recognizing the human's pointing gesture. This is achieved by the robot reflecting on its own experience when it performs the same behavior and subsequently learns the appropriate behavior for assisting the human. An extra benefit of the approach is that as the robot accumulates manual skills, as well as expressive and receptive behavior, The robot's ability to use actions to model humans is enhanced. Furthermore, these behaviors can also be archived as properties for describing humans. In my dissertation, I provide learning examples where a robot begins with an initial concept that a human is just a big blob that moves. And later, this simple model evolves into complex kinematic structures that afford simultaneous tracking. As the robot gathers more interaction experience, the visual tracking model expanded to include social behavior patterns, such as a human is likely to offer assistance to out-of-reach objects if a pointing gesture is used. For more details on the subject, stay tuned for future video updates or check out my papers and the upcoming thesis.